Here I will take you to the next level. So as we discussed in the earlier case, L naught bar due to system of particles. So here tau naught bar due to system of particles. Yes, now what you can identify here is that O is the reference, R1 bar, R2 bar are the two reference vectors. Yes. Okay, position vectors, and particles 1 and 2 are taken here. Now F1 bar and F2 bar are the two external forces acting on point 1 and 2. Yes. At the same time, these two particles are particles of the rigid body. So therefore, they have got interatomic forces, and there is force between the two. Yes. And this I am showing it as F12 bar and F21 bar. I am sure all of you will appreciate that these two forces are equal and opposite.
Yes, sir.
Okay. So the system of particles 1 and 2 experience net zero internal torque. Why net zero internal torque?
Definitely zero. Definitely.
Huh?
Definitely internal is zero. Total internal force is active.
Total internal force.
7 minutes. Yes, sir. Total internal force is zero.
No, but we see, cool, huh? Cool. See, it's not that, oh, I'll calculate internal force and multiply it with what?
Yes.
No, prove that. Okay, I am giving you the system of particles from the experience net zero internal torque. Prove that.
Like, sir, internal forces can't affect the rotation motion. Like, it can't affect center.
See, I don't want, see, I know. So, but now prove it. Prove it. Prove it means mathematically you should prove it.
Yes.
Yes, everybody please prove it.
F12 bar plus R1 is minus F21 bar plus R1.
Gentlemen, did it. Everybody do it, huh?
Yes, yes.
So you have 2 points here, and you are referencing it from here 4, R1 bar, and this is R2, and this is 1 and this is 2. So this one is F12 bar, and this one is F21 bar. So what we have is F21 bar plus F12 bar is equal to 0. That's what we have. Okay, now we have to get the torque. Simple. So go by the basics here. So what is the torque due to F12 bar? Okay. So the torque due to F12 bar will be R1 bar cross F12 bar. Okay, and if I say F net here, so to this torque I will add plus R2 bar cross F21 bar. Okay, so now I will use the relation. What is the relation? I will get here, let F12 bar is equal to, so here I will get here F21 bar is equal to minus F12 bar.
Yes.
So this I have written simply, so these two are equal and opposite. So I can write here R1 bar, okay, cross F12 bar plus in the sense plus R2 bar cross of minus F12 bar.
Yes.
Okay, so I can pull out F12 bar out here, and then I will get here R1 bar minus R2. Got it? So what is this going to be? This is going to be F12 bar cross R21 bar. This is how we write now. R1 bar minus R2 bar, we write it as R21 bar.
That is
Okay. Now R21 bar and F12 bar are collinear. And therefore this becomes 0. So you should not fumble. You just whatever is given there, just calculate the torque. And this is important. These two relations are important. Okay. So therefore, the proposition there that the internal torque is 0. Torque due to the internal forces is 0. And whatever torque will be there, it is because of the external forces. Okay. But remember, the torque is always due to internal and external forces. Okay, remember that. But there can be situations where the internal forces, in the sense here may not be. See, now there is a force on this particle in this direction towards this. You must not simply take it as internal force. See, this internal force is because of the interatomic forces.
Yes.
So the net torque here is so and so. Okay, we proved this. So the net torque about this, we write this. So this expression we just now proved it is equal to 0. But what remains is R1 bar cross F1 bar plus R2 bar cross F2 bar will remain. So this you can write it as tau bar external plus tau bar internal. So internal one, you just now proved this is equal to 0. And net torque will be the combined effect of the torque due to the individual forces. Right? Okay, done. ಯಾಕೋ ಆರಾಮಿಲ್ಲೇನೋ ಯಾರ ಜೊತೆ ಜಗಳ ಆಡ್ಕೊಂಡ್ ಬಂದಿ ಮತ್ತೆ ಮಾರೇ ನೋಡಿದ್ರೆ ಹಂಗೆ ಐತಿ ಶಿಸ್ತು ಜಗಳ ಆಡ್ಕೊಂಡ್ಬಂದೈತಿ So here there is an elaborate diagram here with reference to the reference point here. So here tau bar will be equal to summation or see this is summation of into bracket Ri bar cross Fi bar. Sorry, the bracket is missing here. Hello.
Sir,
Yes.
cross product.
You should take cross product. See Ri bar cross Fi bar.
Yes. You said summation.
No, this should be summation into bracket. See, this should not be summation Ri into this. That's what I say. This is important.
Yes, sir.
If I will correct your paper, I will cut marks for that. So there should be a bracket here. This is missing. Okay? Right. Because see, you are typing all these things, it appears to be so simple. But you see, now take the keyboard and type R, then bar, then I. Okay? Then cross there, Fi. It's not a joke to type the physics, this one. Extremely difficult.
Yes, sir.
It's very time consuming. Okay, but I am using some techniques and all and doing it. Anyway. So in general, anything?
Sir,
Grammarly you cannot. What Grammarly? It will only correct the grammar. It will not do physics. You cannot do physics. No, you have to type. That's all.
Yes.
You have got in Word. You have got all this, but you have to type. There is no other go. Suffix and all you have to type. Okay. Substitute and all, you see, just to type this, it will take, it's not just taka. You have to spend a lot of time. Anyway, you are all lucky. I have enough time to do all this.
Yes.
I'm doing it. So tau bar is equal to so and so. So where Fi bar is extended, net torque is equal to the net torque due to the external forces. That's what is important. Alright, shall I proceed, friends?
Yes, sir.
Yes, sir.
Thank you. So here is this one for you. Antara refresher. Nadak chai. So chai or some juice. Numerical problem. Solve this numerical problem. So uniform disk of mass m radius r rotating about a vertical axis, passing through its center and perpendicular to the plane is placed gently. It's already rotating. So it is gently placed on a rough horizontal ground. Rough means friction is it. Where coefficient of friction is mu. Calculate the torque of the frictional forces. Cool. First of all, you see friction mu is given. What sort of mu is that? Is it mu s, mu k, or mu r?
Yes.
Sir, in my case, it is sliding, sir.
You are not even sliding.
All of you put your head and say, see, that's what you know, that's what I'm telling with caution. So the body is turning. So mu is given. You will treat mu as what? Yes, everybody there, make an opinion.
Okay on this.
You are confident, you are telling. What about others? What about the
Sir,
Arun?
you don't know condition whether it's sliding or not sliding.
Yeah, it is rotating. You didn't understand the problem. There is a disc which is rotating and you placed it on the table.
Yes, sir.
Then what? Yes, sir.
Sir, after placing it on table, sir.
It is still rotating.
It is still rotating.
Uniform is
Sir,
not
then
rotating.
you should
Vertical
use
axis.
US. Then
Once
you
placed gently on the rough horizontal where the coefficient of friction is this. So it is rotating. You gently placed it.
even after placing also it's rotating without placing.
At least at the time of keeping it is rotating.
Yes, sir.
ಈಗ ನೀನು ಯಾವಾಗ ಯಾವಾಗ ತಿರುಗಿಸಿ ಕೆಳಗೆ ಬಿಟ್ರೆ ಏನು ನಿಂತು ಬಿಡ್ತೀಯನ ಸ್ವಲ್ಪ ತಿರುಗ್ತಿಲ್ಲ ಏನು ಸರ್
Then you should use US.
ಏನು ಯೂಸ್ ಮ್ಯೂಎಸ್ ಯುವರ್ ಗಾನ್ ಕೇಸ್ ಮ್ಯೂಎಸ್ ಈಸ್ when the body is at rest man with respect to the reference ground it is at rest then you will use mus just about to move where are you
Sir, that particles going to be new.
louder you please tell loud come on tell
That particles on the disc, sir,
Huh.
when it's rotating, sir, when it comes to contact of ground, there are different particles.
different particles are also different particles are there correct
Sir, the different points are coming, sir.
yes
Respect.
Huh.
So, like for the condition of rolling also, sir, we use the US.
see you have I'm very sorry what is this rolling man rolling is what are you talking see rolling is see if it is rolling like this if this is rolling like this and if there is some hump here and this wheel will get deformed then the rolling friction will come have I not told you and that is not for your syllabus so don't keep that in your head
Yes.
this disc is rotating man
Yes.
it is rotating like this
Yes, sir.
then the friction between this and this is what see this is sliding with respect to ground no
Yes, sir. Yes, sir.
then mu k will come
Yes, sir.
see you have solved so many problems in college okay and this is the natija because that is what when the problems were solved in the college they just wrote formula and they did it and what happened you did not apply your mind to see what is the science behind it what is the mechanism now aram say see the body is rotating it landed here and it's going now you see whenever there is a sliding motion between the two then mu k will come see now the body I am applying force is it moving
Sir, no, sir.
tell her
No, sir.
is it moving
No, sir.
I am applying 1 Newton 2 Newton 3 Newton now what is the friction when I am applying 1 Newton force so the frictional force is also 1 Newton
Yes, sir.
2 Newton 3 Newton 4 Newton exactly 5 Newton it just starts sliding
That time, no, sir.
that time US will come
Yes.
and once it starts sliding UK will come don't forget this fantas so UK will come so whatever mu is there it is UK everybody got it
Yes, sir.
so now
Yes, sir.
so uniform disc of Mahasiam radius are rotating about a vertical axis passing through its center and perpendicular to the plane is placed calculate the torque of the frictional forces you have to calculate the torque the mass of the body is given the radius is given and mu is given calculate the frictional forces Aram se draw the diagram so if this is the ground the disc is here and this is the axis of rotation it is rotating like this see if this disc if this body if this disc here if this disc was not rotating okay this mass is m, radius is r, friction coefficient mu. If this is not rotating, okay, but it is sliding. This disc is not rotating but sliding. Okay, then the friction here is what? Mu mg, right? Mu k into mg. If it is moving, then the friction is this. Okay. Now also it is same. Now only thing is it is rotating. Okay. So, but there is something very interesting when it is rotating.
Normal is not.
You know?
Sir, normal is not. Normal. But
ये सब जोर मत रखते. See, you be confident. If you see whatever you are telling, be confident. Normal is what?
sir, like it's not the same.
Normal is not same. Why?
Not same means you can't take the same normal mg same.
You can't say why this is also on the ground. This is also on the ground. Why you can't take the same normal?
Sir, that practically, like, sir, the entire mass is not that.
Hey, normal is what, man? What is wrong with you? Why the normal is not same? Normal component of the force will balance mg. That will not be different. See, the question is torque due to the friction. So now consider, so this is for the translation. Now consider the view from top view. If you see here, the disc is rotating, you are seeing from top view.
Yes.
So if you see this from the top view, so from the top view, you are seeing the disc,
Yes.
right?
Yes.
And the disc is say rotating,
Yes.
omega. The disc is rotating, right? Now the question is, from the center, if you take this point, this is at a distance smaller. Okay, at a distance smaller.
Yes.
Okay, so these are the things which are at a distance smaller from this. Smaller from this. Okay, now there is frictional force going to act on this.
Yes, sir.
What will be the frictional force that will act on this? Okay, the total mass is m.
Yes, sir.
The total area is 4 pi r square.
Yes.
And the area of this incremental mass will be what? Sorry, either of anything who m divided by pi r. Okay, into 2 pi r dr.
Yes.
Okay, so this will be equal to what? This will be equal to dm. What dm? The mass of this small elemental ring.
Yes. Yes.
Mass of that elemental ring. Right? Now, this mass of this elemental ring, this minute, and just use the board very judiciously. Okay, this mass of the elemental ring that you see here now has got mg. Okay, so the normal acting on this elemental ring, the normal acting on this elemental ring will be what? dm into g.
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
So the frictional force on this ring, the frictional force on this ring, df, frictional force will be equal to mu dm into g.
Yes. Yes, sir.
But the important thing is this dm here, if you say mu mg, dm what did we get there here? So here pi will go, okay, small r dr will be there, so m by r square will come out, and into bracket m by r square is coming out, so 2 also will come out. 2 mgm r square will come out, and what will you be left inside? R dr.
Yes.
So now what you have to see is the frictional force on this ring of this portion of the disc is dependent on its proximity from the axis.
Yes, sir.
So that means now this part of the disc will have some frictional force, this part of the disc will have another frictional force, this part of the disc will have another frictional force.
Yes, sir.
Yes, sir.
Okay, and if you say the disc is rotating like this, then the frictional force on this disc is tau. And as far as this point is concerned, the frictional force is R. Correct?
Yes, sir. Yes, sir.
So therefore, the frictional forces at every point will have a corresponding friction which is equal and opposite.
Upon it, yes.
And therefore, the net force due to friction, is 0.
Yes, sir.
Therefore, the disc is only rotating, it will not translate because of the frictional force.
Yes, sir. Yes, sir. Yes, sir.
Got it? Huh. But yes, its rotation will be hampered.
Yes.
Huh. So why it will be hampered? Now you calculate the torque, d tau bar. So d tau bar will be what? R bar cross df r bar.
Yes, sir.
Yes.
So this is the elemental torque, right? Huh. And since this angle is 90, so this gives you dr, okay? dfr into r. You get this torque, okay? So I'll just remove this. Okay, you will get this torque, correct?
Yes, sir.
Some listen, dfr into r, you will get the torque. Okay, friends, are you with me, all of you?
Yes, sir. Yes, sir.
Huh. So now you see, so I can substitute the dfr here. So therefore, I will get here d tau bar. Sorry, I'll write only the magnitude now. D tau will be equal to, so df, I got it as 2 mu g L by r square. R dr will become what? R square dr.
Yes.
This r will multiply with this r.
Yes. Yes.
So you get tau is equal to integration. So this integration will be 0 to, so this is 0 to tau and this becomes 0 to r, capital R. Okay, so that should straight away give you 2 mu m g by r square into r cube by 3.
Yes.
So this distribution goes, only one r will remain. Take it here, 2 mu m g 2 by 3 mu m g r.
Yes, sir.
Right, and so that sums up, because you see now common sense will tell us that the friction, the torque will depend upon the coefficient of friction, the torque will also depend upon m into g, and the torque will also depend upon the radius, right, the further radius. So the torque due to friction is, the torque due to friction is so you get this.
Yes.
Okay,
Yes, sir.
nice now, very interesting. Right.
Yes.
See, I will remind here, I'll show you how the frictional forces act on a bicycle when it is in motion. I'll show you a wonderful video which is prepared by a village school teacher. And I will give full marks. Even at the international standards, it is the best. And if you see that explanation, you will understand how Abdul Kalam ji, Narayan Murthy, okay, all these wonderful people, how did they become wonderful engineers? They all studied in simple government schools. And they were taught, I will show you the video, how physics was taught. Okay, and that's the way to learn physics.
No, sir.
Not now, I'll show you. I've got, okay, right. So that's it. I suppose you got this, friends?
Yes, sir.
Hello?
Yes, sir.
Now, let's see whether whatever we did was right or wrong. Okay, great. Let's enjoy learning.
Yes.
So, first of all, Yes, we got 2 by 3 mu mgr answer. Okay. So
Yes.
here goes the theory. df is equal to so and so, diagrammatically opposite, etc. We have also taken this. And finally, we also got this integration with this. Okay? Right. Be happy.
Yes, sir.
Be happy.